All right, so here's what we're going to do tonight. We're going to cover sections 1.1 and 1.2. All right, we'll come back and do 1.2 a little bit more on Wednesday, where we're actually going to do a little Desmos activity I think that you'll like. Most groups have enjoyed that. And then we'll do some other things with 1.3, okay? 1.1 is the heaviest of the two sections. There's a lot of stuff in it, so we'll just kind of go. And again, I can't emphasize to you enough how I want you to ask questions. I know some of you don't have a textbook. That's okay. I'll do what I can for you to help you out. And if we get time in class to where you get to practice a couple problems off your assignment, that's great. And then we go over those. That way, I feel better knowing that you know what we talked about. So hopefully that's always the goal. We just don't always get there because we get tied up in things. So that's enough of that stuff, I guess. So here's what we're going to talk about in this part is, in the beginning, we're going to talk about what a relation is versus a function. Okay? And then we're going to do a lot of things with functions, kind of analyzing them, I guess. I don't know what we want to call it, analyzing functions. Okay, so that's kind of what our topic's going to be, looking at functions quite a bit, but first we got to talk about a relation, all right? So, a relation is a correspondence between two quantities. Okay? Now, I'm not gonna ask you to write definitions on your test or quizzes. This isn't something I would ask you to do. It's just some information. All right. No more times I'll say, hey, this is going to be on your test or this is going to be on your quiz, okay, so that you know. But I'm not going to ask you for definitions, okay? So a relation is a correspondence between two quantities. That's what it is. So if I have one of the things I like to always talk about when it comes down to relations and functions is money, because people understand that pretty well. Okay, so if you have a hourly wage job where we have time here and wage here, okay, 0, 1, 2, 3, 4, okay, 0. We'll say you got a nice little efficiency, so that would be 21, 32.50, and 43. Okay, so something along those lines. All right, this is a perfect example of what a relation looks like, because you've got a quantity here in time and a quantity here in wage, and there's a correspondence between them. Okay. All right, so that is what a relation looks like. But it doesn't just have to be like that. It can be anything, really. We could make it different where we have time and we'll just say money here in this case. And maybe this is back in the old days where you might work on some sort of a commission thing or something like that. Maybe you had really good there, and then this was 70, okay? Something like that. Again, it's a correspondence, okay, between two quantities, time and money. It's just a different situation. And maybe you've got one where time, money, 0, 1, 2, 3, 4. And it doesn't make any difference when you show up. You're going to make this amount no matter what. Okay? Right? It's maybe on a salary or something. So that's going to be what it would be maybe for a day or something. Okay? So, still, this is correspondence. Right? And it doesn't even have to be numbers. All right? You could have yourself, the person's name, and a birth date. Okay. All right, that's a correspondence. Okay. It doesn't have to always be numbers. Okay. It can be yourself and an address, maybe where you live. All right. Could be something like that. Okay. And it could be a situation where we have a phone and there's a number associated with that. Okay. So it could be anything like that. It doesn't necessarily always have to be a number related thing. Okay. So that's what a relation is. It's just a correspondence between two quantities. All right. That's what it is. So, but we're interested in functions because if this was an abstract algebra class, you'd be more interested in relations, but we're not. So this is just a regular old pre-cal, I guess, class. So we're interested in functions and what that is. Okay, so functions are relations, but they have that have one element in the domain. Oh, I should say each element, sorry, not one. Each element in the domain, we'll talk about that in a little bit here, has one and only one paired element in the range. Okay, I'm going to stop for a second. So functions are relations that have each element in the domain that has one and only one parent element in the range. All right, so each element in this thing called a domain has one and only one element in the range. All right, that's what a function is. Okay, some of you probably already knew that. So what does that exactly mean? Well, if we go back up to these guys up here, okay, this one is a function because here's my domain. This is the input. Okay, so if I have a time, I have a wage or amount that's associated with that. Okay, so this is an input. This is an output. Okay, so we'll talk a lot about input and outputs dealing with functions. So this here is an input because I'm putting something into it, and this is the output because I'm getting something out. All right? Input, output. So this is a domain. That's what it's called, and this is the range. All right? So what it says is that each element here, so each one of these numbers has one number paired with it. 0, 1, here, here, here. Okay, so this is a function because there's just one. All right. Over here, this was the one I said was the old time commission stuff. All right, this is the input, still the input right here. That's your domain. Okay, here's your output here, the money you're going to get. All right, so we want to take a look and see if this is a function or not. So we have 0 to 0, 1 to 0, 2 to 20, 3 to 60, 4 to 70. Yep, that's good because each element in that input, which is the domain, has only one in the range. All right, so let's do this guy. Now we have this one, input, output. Okay, so 0 goes to 500, 1 goes to 500, 2 goes to 500, 3 goes to 500, 4 goes to 500. For some people, they probably say, nah, that's not a function, doesn't work. But actually it is, because 0 still only goes to 500. right? If the input time is 0, you're still going to get $500, right? It's still going to be just 500. 1's 500, 2's 500, 3's 500, 4's 500. It's still a function. All these are okay. They are still all functions, okay? All these are functions. All those are functions. They're all functions. Okay? But what isn't? Okay, so then if all those are, well then what the heck isn't a function? Well, it's really hard to do one that has to do with time and money, because if this is time and this is dollars, okay? So how's that going to work? Well, it would look like this. Maybe this will go to 0. Maybe this will go to 8, 16, 24, 32. But for some reason, 3 also netted you 48. Okay? Well, that doesn't make any sense, because either I work 3 and I get 24, or I work 3 and I get 48. Which one is it? Okay, I want 48, obviously I don't want 24. But this is not a function because this number shows up twice. Okay? And it's going to 2 different things. All right? So that makes that not a function, because now the input has 2 different things in the output. All right? It has 24 and it has 48. So it has 2 different things. All right? So that makes this not. This is not a function. It does not work. Okay? So that one's not. All right? Based upon the fact that inside that input, that domain, there are 2 numbers, or there's 1 number and it's going to 2 different things. Okay? You can't pay somebody 2 different things. You either pay them one or you pay them the other. You can't pay them 2. All right? Okay? So that one's not. All the rest of these are, though. Even the last one is 500. It's okay. They can all be the same. So what about these non-numeric things? What about name and birthday? What do you think? Function? Does anybody here have 2 birthdays? No. See, so that's a function. Okay. You only got 1. All right. How about your name and address? Is it possible for somebody to have 2 physical addresses? Then that wouldn't be a function. Okay, if you had 2 physical addresses, then it wouldn't be. Okay, so this might be no. All right, here's one I didn't know about till this year. Student pointed it out to me, but phone and number. What about that? Does your phone have 2 different numbers? It can. Yeah, it can. Yeah, somebody pointed. Oh yeah, I get 2 different numbers from my phone. I go, oh, okay, well that's probably how those telemarketers call me and show me with that's one of my contacts or something like that. Okay, so no, this would not be a function then. Okay, if you've got 2 different values, then that would not work. Okay, it's not a function, right? Because it has 2 different things. Right? So there's a lot of different. I mean, numerically, it's easy to show what are functions and what aren't, but these things maybe aren't as easy to understand, right? Because of the fact that, hey, my phone can have 2 different numbers, I guess. And I could have 2 different physical addresses. Email's another great thing. I got 3 of them. So there you go. Most of you have a number of them, work one or whatever, school. So it's not a function. It's got to only be one, not the other. All right. Any questions on that, what we're doing there? Okay. Got to ask questions if you have them. All right. So functions and relations, that's the difference. A relation can be anything. All those things are relations. Functions, that's a whole different story. If you look at it, mathematically, they'll in your book, when you see stuff, they'll do things like this. They'll either, let's see, do they do the actual, they kind of use boxes, okay? I've seen it both ways. So some go boxes and box like this. And then they say this is a domain because that's the input. Okay, here's the range because it's the output. All right, and they might have this kind of a setup here. and they'll have arrows drawn. Okay? And they're just basically saying, hey, you know, this 1 goes to 50, 2 goes to 10, 3 goes to 20, 4 goes to 40, 5 goes to 30. All right? That's the correspondence. And they'll ask you, you know, is that a function? Well, is it? What do you think? Yeah, right? Yeah. Every number is going to a different one. That's okay. All right? It's okay. So this one is. All right? And if somebody said, hey, can you list out the domain? And they will. Okay? Then you would go like this and go 1, 2, 3, 4, 5. That's what the domain is. And if somebody says, hey, can you list out the range? Sure. Okay? 10, 20, 30, 40, 50. All right? There it is. There's a domain, and there's the range listed out. Okay? Input, output. Sometimes they show them like this. They have like little bean shapes. I've seen this before. Arrows. Okay. Is that a function? Why not? What's wrong with it? What is it? For which number? All right. 3's going to 2 numbers, huh? Okay, good job. So, doesn't work. Okay, it's not a function. All right, so this is no. Not a function. Okay. Does it have a domain and range? Yeah, technically it does. I mean, the domain's still 1, 2, 3, 4, 5, and the range is still here. It's just it's not a function. But I've seen them written like that before. Okay? Your book doesn't write them like that. They put little boxes around them. Right? But it's all, that's what they do. Okay, draw some arrows. Ask if it's a function or not. Right. Oh, they might do this too. This is pretty common. Okay, so they give you the little fuzzy brackets, I call them. Little curlicues here, and they'll go like this. 1, 3, 2, 5, 3, 7, something like this. 4, 9. Okay, and they want to know, hey, is that a function or not? All right, so then you got to look at it. There's no boxes. It's just enough. What do you think? Yes. Okay, 1, 2, 3, 4. We're all matched up to one number, so we're good. So yes, this is a function. Yep. What's the domain? 1, 2, 3, 4. See, I get real creative with this stuff, don't I? I got the same number every time. Okay. All right. Here's the range. What's the range? Yeah. There you go. All right. Okay. Now, with that said, these look like points. Okay. So, which one of these would be our x points, domain and range? Which one's the x's? The domain's your x's, okay? X, y, x, y, x, y, x, y. All right. So domain's your x's. Okay. So these are your x coordinates every single time. Right here. Which means the range is going to be your y coordinates every single time. Oops. Function? Why not? One is two different numbers. Okay? One is two different numbers. This is no. All right? Okay. Function? Okay, a little tricky because we got 8s and 9s, but we're not looking at those. Okay? They can repeat. That's all right. It's the x's that you want to look at. All right, see how this one had a 1 and a 1, so we already picked that up. Okay, this is yes. All right, it's okay. What's the domain for that one? Hey, how about that? Don't worry, it's not all going to be that way. What about the range? 8, 9. You don't have to write them twice because it's just 8, 9. Okay, you don't have to do that. All right. Cool. Good. So this would be a good spot. So you've been here about an hour. So go take yourself about 5-minute, 10-minute break, whatever. And when we come back, we'll do some Desmo stuff and some graphing and find out some more things about functions. Okay, so we'll kind of pick up here. I want to do a little bit more with the domain and range thing. I want to go, let's just take, I'm just going to do a little graph here by hand. All right. So this down here is our domain because that's our x's. We said that. And this is our range here. This is our y's. So let's say we just had some sort of a graphical relationship here. Okay, something that looks like this. All right. So I don't really have any numbers paired up with anything. But does that look like a function if you saw that? Yeah. Okay. 1, that goes there, that one goes there, there, right? Okay, so this is good. So let's say I have the same graph, but now I'm going to put it in red. All right, so let's say I do this. Is the red one also a function? Yeah. Oh, okay. So let's say I do a green one here. Is that one? No. Why not? Because on the y-axis, what's going on? Who's talking?
Oh, on the y-axis is 2 dots that are on top of each other, so 2 of the same number.
So right here?
Oh, yeah, I guess the next. But yeah.
That's what you're talking about?
Yes.
We're on top of each other?
Yeah.
Okay. So this one, whatever number this is, maybe it's 5, maybe it's not. That has a number there. It has a number here associated with it, right?
Yeah.
Two different outputs. Good. Okay. So that one isn't. Now, in a graph, okay, there's a really easy way to test to see if something's a function, all right? I'm thinking most of you probably know what it is. Do you know what it is? The vertical line test, okay? Good. So the vertical line test basically says, okay, if a vertical line, you can put the word touches, intersects, passes through, whatever you want to put there, it makes sense. Okay? whatever you want, a graph in only one point, okay, one spot, okay, whatever you want to say, then the graph is a function. So this vertical line test idea, all right, is something that we use quite a bit. All right, not only in this class, but as mathematicians and so forth. Okay, vertical line test tells you if a graph is a function. All right, because we have Desmos, the graph for us, it's so powerful that we don't, if we have the vertical line test and we have a graph, we visually see what's going on. Man, that's great. Okay, so this thing really saves us a lot. All right, and we can check, and I can take a vertical line and pass it through the red one, and it only touches that graph in those spots. Okay, same with the purple one. All right, I'm only getting 1 point and it touches it. But as soon as I hit this green one, that's good. But right all of a sudden, right here, see that vertical line touches here and here, touches it in 2 spots. So that's why it's not a function. Okay, the vertical line test helps us with that. So when we start graphing things, right, and the book starts throwing problems at you, or I throw problems at you on a quiz or a test, and I say, okay, you know, we've got this graph here, like this guy, all right, which you've seen again before. Right, if I pass the vertical line through, and I didn't draw it real well, but okay, it's really only hitting in one spot. Okay, here I kind of get brought inside a little too much, but it's still, that's a function. Okay, it only hits it in one spot. All the vertical lines I pass through there, okay, one spot. Okay. Right here, one spot. But as soon as I draw something different, like that, then all of a sudden, I'm hitting it in 2 spots. And it only has to happen once. Okay, as soon as that vertical line hits that graph in 2 spots, no matter where it is, boom, it's not a function. Okay, so this is no. Not a function. Rest of them, we're okay. All right, rest of them are. All right, but that one is not a function. So you're going to get graphs. I'm going to give you some graphs. Okay, book's going to give you some graphs. You got to look at them and decide, are those functions? Run a vertical line through it. Take your pen or pencil. Do this, whatever. Okay, is it going to work or if it's not? All right, let's do this now. Okay. All right, we're going to go into Desmos. All right. So I've got to switch from here to here, all right? So this isn't getting recorded. Now, if you've never used this before, I'm going to assume that you never have, all right? So I'm going to open up this little browser here, okay? And I'm going to go Desmos. Now, it works on your phone also. There's an app you can download. I've never downloaded the app and using this thing for I don't know how many years. All right, I've never downloaded the app on my phone. I just access it through the net. All right, but I think I have it on my one tablet at home. So anyway, I should download the app on this thing, but I school protected, so I can't. All right, here we go. So I go to Desmos Beautiful Free Math Graphing Calculator. All right. Now, the nice thing about it is a calculator, and that if you want to put numbers in here, okay, it'll figure them out for you, and it does it exactly the way you type it in. So look at this mess I got here, all right? It's also a calculator, okay? This thing does everything you ever want to do as far as calculator, graphing, whatever, all right? You can get onto it using this, like I said, on your phone. So here I am. I'm going to type this in. I'm just going to go y equals, okay? I'm going to put square root of x minus 5. There it is. It graphs it for me. I can slide this around, you know, by whatever we want to call that with your fingers, okay? Slide it around, right? You can get a graph of it. If you want to, you can just simply up here hold that down and you can change the color, right, to something if you want to see it better, right? You can do that. That's kind of neat, all right? Up here, if you hit the graph settings, all right, you can change the X and the Y axis scale. Right? And a lot of times this is kind of handy to be able to do. You can swipe on there, okay, but swiping just changes it in both directions, whereas this is just going to change it in one direction. And I don't know if we'll get one. We might get one or two graphs here where it's easy. It's better to use this one than it is to use the swiping, okay? Click off of that. You can zoom in and out, right, this way, and this always takes you back to home. All right, I'm going to look at this graph here, okay? Is that a function? Vertical line test, okay? See, it doesn't like that very much. It must think, I can't put a slider in there, so I won't do it. But this is, again, I can run a ruler through there, okay? Whatever it is, it's going to be a function, all right? Now, well, let's just do that, okay? Let me get rid of this guy, turn it off. Come down here, I'm going to put another one in. You don't really have to put y equals, I just always do. There's a nice little parabola. Is that a function? Okay, vertical line test. I know you don't think it. There's got to be one that's not. Let me change the color of this so that you get to see something different. There you go. What do you think? Function? No way. Look at this. Vertical line test right here. Boom. Doesn't work. Okay. Doesn't work. Kind of a creative looking thing, but it's not a function. All right. So there's a, I mean, you know, it's that easy putting things in here. Okay. I'll try another one here. Y equals parentheses. Sometimes you'll see some of these. This is kind of crazy because this textbook, I really don't understand why it does things this way. I really don't, because these are called rational functions, all right? And we spend a whole chapter on these at the very end of the term, but then they bring them up now. I don't know. They just bring them up and expect you to know how to do it when really they're not. They should all just not even have these here now. They should wait till the end, but they don't. Okay. So this guy here. All right. What do you think? Yeah. I mean, maybe it doesn't, but look, if you pass a vertical line test through there, okay, it just doesn't hit. All right. Never touches one. Okay. Just never does it. All right. So that makes that a function. All right. So it's crazy. I mean, there's a lot of different things that are functions. Like here's another one here. I'll show you this, y equals. Well, you know the answer. This one's going to be functions because here it is. It says they're functions, right? We're not going to do any trig ones. But if you hit miscellaneous, all right, you'll get some, like this would be a cube root or a fifth root if you ever need to do that. Okay. So I'll do one of these. Say we'll put a cube root or something in here. All right, there's that. Okay. So underneath this thing gives you different things you can do. A lot of stuff we won't mess around with too much. All right. But I want to show them to you anyway. There we go. Okay, we're done with that. But that's how you enter things in Desmos. It's pretty darn easy. Right? You just graph it, and it's so nice. It's just the greatest little calculator thing that was maybe ever made. It's really nice. So we're good with that, I think. Oh, where's I was one more I was going to do. I thought it was in the functions, but I guess it's not. Right here, the old absolute value. You get a nice V shape there. All right. Function, yes or no? Yeah. Again, passes the vertical line test. Even though if I go to this number, okay, and I put 4, negative 4 is 4, and positive 4 is 4, right? So I get 2 4s in the range, but that's okay. It's all right to have that. If this positive 4 went to 4 and went to some other point up here somewhere, then we'd be in trouble. You know, so like if I even went down here, watch if I go 4, 8, and I say, oh, that's part of this now, okay? And I made this green, like this, and I said, oh, is this a function, right? There's a problem because 4 goes to 4 and 4 goes to 8, so then that would definitely be a problem there, okay? If this was part of it, if I just gave you this graph, you not knowing what that is, but absolute value is. So we're good with that. Vertical line test, really nice thing to have. Let's see. While we're in Desmos, let's continue to do some stuff here. I'm going to turn this off, leave the rest of these here though. I'm going to get rid of this guy so I don't want it. And let's do this one, okay? Turn this back on. So what we want to do is talk about domain and ranges of graphs, because you're going to get some of those where it's going to give you a function, and I'm going to give you some functions, and I'm going to say, hey, I need you to tell me what the domain and range is, okay? This is probably one of the single most difficult things for people to understand. And I wish I had the magic wand to say, there you go, now everybody understands it, but I don't have the real key idea on it. But I will say that the best thing I think to do, here's my graph, okay? We said the domain was, which one is that, X or Y? What did we say domain was? X's, right? So what I'm going to do is take this graph, and I'm going to fold it down on the x-axis, okay? So I'm just going to kind of bring it down here so that it's on the x-axis, all right? Once I do that, it's going to start right here at this point, okay? There's nothing going on back here, but a whole lot of stuff's going on over this way. So that means that my domain is going to start at that point, at 5. So then what I would say is a domain is greater than or equal to 5. Okay? Domain X is greater than or equal to 5. Right? You could write it like that. Okay? In a number of my classes that I've had, some people say, well, can I write it using interval notation? You know, if you want to, sure, go ahead. Okay. If you've seen that someplace and some teacher made you do it 1,000 times or you like it or whatever, so you can write it like that. Okay, it really doesn't matter to me, but that's what the domain is. Okay, greater than or equal to 5. All right. The range. Okay, if domain is x's, then what's the range? Y's. All right. So now it's almost like I got to take this thing and go this way with it and put it up against the y-axis. Okay, so it's going to kind of hinge like this. Okay, it's going to kind of hinge on that point. When it hinges, then I'm looking at all the numbers that are greater than 0. Okay, so the range of this, all right, is y is greater than or equal to 0. And if you want to write it as interval notation, you can. It really doesn't make any difference to me. I just want you to be able to communicate it to me. All right? I don't even care if you say it out in words. It doesn't matter. But we're just going to hinge this thing. Nothing's going on down here, but everything's happening up there. So that's how you kind of do domain and ranges. All right? It's not real simple to do. Let's try another one. Let's try this one. All right? So, domain. Bend it down. Pin this down here, pin this down here. If we did that, what would the domain be? What is it? Negative infinity to infinity, okay? So you could write that. You could say it's negative infinity to infinity, right? You could go negative infinity to infinity in interval notation. Like I said, some people like that, okay? Or you could just say, you know what, it's all real numbers, all right? All reals, like that. And you can say that, all right? Because that's what it is. That's just a real number line with everything on it, so it'd be all real. So we bended it down, okay? Bending it down, covers everything. If I zoomed out enough, you probably believe me, all right? That thing keeps tapering, okay? So I'm going to cover everything on this x-axis, right? What about the y? So now, range, we're going to kind of hinge it here together, okay? Throw it up against that y-axis. So what would the range be? 0 to infinity, right? So you could go y is greater or equal to 0, or again, you could do 0 to infinity like that. Notice when I do it in this form, okay, I'm assuming that you're familiar with this. If you've never seen this, don't use it. Use this stuff, right? But basically, the parentheses means that it doesn't include that number, and the bracket means that it does. All right? So, again, if you haven't seen this interval notation, you'll see it later, so it really doesn't make any difference if you know it now or not. All right? I'm going to dump this, get rid of this guy. Let's do this one. Okay? The irrational is a little harder. So let's do this one. What's the domain? Negative infinity to positive infinity, okay? Or would we say that simply was? All real numbers, right? It's just all reals, okay? It's all reals. What about the range? Greater or equal to 0, okay? Bring it into that y-axis, fold it in. All right, see what it is, okay? Let's swing this down. Let's do this. -3. All right, there we go. Now it's -3 to positive infinity, right? Okay, -3. Again, what we're doing is just folding that in to that x-axis, okay? Or to the y-axis. Sorry, fold that in to the y-axis. Okay. Good. Let me see, what else do they throw at you here that you need to know as far as the domains, and you can graph them. I don't know if they're this is what you're just asking about domains. Some of them they ask you domains and ranges, but these are just just domains. Oh, let's do this one. I'm going to get rid of this guy. This is easy. Y equals. I'm going to do this. X plus 2, and I'm going to add this slider. So this is a line. Let me change the color so you can contrast it here a little bit. There we go. Okay, so here's a line, all right? Fold it down, fold it up, fold it down, fold it up. What's the domain? All real numbers. Okay, what about the range? All real numbers, right? And no matter what I do, okay, to that A value there, it still doesn't change, right? Domain's still all real numbers, no matter what I do. Okay, range is all real numbers. It's just teeter-tottering right there on that point. Okay, which means if you have a line, what are you going to say the domain is? What are you going to say the range is? All real numbers. Okay, the lines are always going to be that way. You know, unless they're restricted or something, the domain and range is always going to be all real numbers. All right, I'm going to get rid of that one. But you thought that was probably pretty cool. How about y equals x to the third? Makes this kind of a neat looking graph. What's the domain? All real numbers. What's the range? All real. Range is kind of easy there. You just fold it against the y-axis and it tells you what it is. All right. So there's domain and ranges. You're going to get all kinds of graphs. You know, you just got to kind of sort them out, all right, and do that kind of thing. Okay, so I'm going to switch back here to this guy, and all right. So let's summarize just a little tiny bit here. So if we have a graph that looks like this, nice wide U shape, okay, domain, all real numbers, all reals, okay, range, y greater than or equal to 0. If you want to write an interval notation, you can. All right, if you want to keep it like that, you can also, okay. All we're doing for the domain is we want to shove this graph down, and for the range, we're going to fold it up, okay, fold that thing up so it covers everything there. All right, that's how we do that. Okay, so that's domain and ranges. One of the things, like I said, that the book does is they're going to ask you to find the domain, and they're going to give you some things like this, okay, and they're going to go y equals, all right. Well, actually, they're going to, let's be consistent with what they're going to do, so that, all right, f of x equals. So f of x is just a symbol for a function, okay? Functions can be named by anything. You call them f, g, h's. Those are the most common ones, okay? You can call it time, you can call it ted, you can call it anything you want, all right? The name of the function here really doesn't make any difference. This thing, this variable has to be the same as the variable that's inside of that function, though, okay? So you couldn't say this is f of t and make that an x. All right, that doesn't make sense. So those two things got to be the same. All right, so here we go. F of x equals 2 over x plus 1. All right. To find the domain, now you could graph it in Desmos, all right, and I'm not going to fault you, okay, because I just told you at the beginning of class that you can use Desmos as a tool on test quizzes, whatever, right? I can't, if I said that, I mean it. You can do it, all right? But think about it. So, is there a number that you can never divide by? 0, right? You can't divide by 0. There can't be a 0 down here. 2 divided by 0 does not work. Right? So, you could just look at this and say, well, here's what I'm going to do. I'm going to say x plus 1 is equal to 0. When is that going to happen? What does x have to be to make that a 0? So then I could just say x cannot be negative 1. All right, and be done with it. I don't have to say x is every number but negative 1. I can just say x can't be negative 1. Everything else is good to go. All right. If I graph this, all right, and you can go ahead and do it because you got Desmos in front of you. Here's what it's going to look like. It's going to go like this, and I think you're going to have something like this, and I think you're going to have something like this. All right, and at negative 1 right here, okay, it's going to get real close to it, but it's never going to touch it. All right, and if you trace on it, so if you're using your phone, if you hit it on here, it should show a point in its coordinates, and you can trace it as far up as you want to go, and you can trace it as far down as you want to go, and that x coordinate should never be negative 1. All right, it should never be there. If you get to be exactly negative 1, it probably says undefined. I think that's what it says. If you use your mouse on you, you do the same thing, okay, you'll see. But it's really hard to pick that up. You know, I mean, you can look at it and say, well, I think what it is, so you kind of got to trace on it really to see it in one of those rational types of functions. Okay, that's why you're almost better to just go ahead and look at it and say, oh, I can't have a 0 on the bottom, so that's going to be my problem. All right, I can't have that. Oops. Same thing with these guys. So if they have something like this, I'm looking at some of your problems that are right like off of the homework here. All right, something like this. Okay, you can do it in Desmos. Take a look at it, see what it looks like. Right, you can do it that way. Or you can say, you know what, I'm just going to look at this, set this equal to 0, because I know I can't have 0 down there, and figure out what x can't be. Okay, so what can't x be? It also can't be -3, right? Because -3 squared is also 9. Okay, so it can't be that either. All right, so in this case, x cannot be plus or minus 3. All right, and if you graph it, so let's see, 3, I'm thinking you're going to get maybe something like, let's see, this should go down to 0. Something like that. I think that's what you're going to get. Okay. All right. And you can do it in Desmos. I'm not telling you can't. It's just some people might think it's a little bit harder to figure out what it is that way. You can visually see it, but it's not always that easy. We did a square root. Okay, we did a square root in Desmos, figured it out, and yeah, it works. I wouldn't even, Desmos might be a better way on this. But again, if you think about it mathematically, what number can we take the square root of? What kind of numbers can you take the square root of and get a nice real number for an answer? Well, we can take square root of 5, just not nice and pretty, but we can do it. What can't you take the square root of? Can you take square root of a -4? No. You can't take the square root of any negatives. Okay? So then what you'd have to do here is say, well, I want 3x minus 12 then to always be greater than or equal to 0. Add 12, 3x is greater than or equal to 12, so x has got to be greater than or equal to 4. Okay. All right. And again, you could do that in Desmos if you typed it in and you got the same answer. All right, but they're just saying that you can see it from a different point of view also, looking at it mathematically. All right, so I really don't care which way you do it. I just want you to get the right answer and understand it. If you want to use Desmos, go for it. If you just want to do it this way, then do it this way. Okay, it really doesn't make any difference to me. I just want you to understand it and get it right. Any questions on finding domain or ranges from a graph? Okay, make sure you ask questions if you don't know it. I told you this first section's got a lot of stuff in it. Okay. All right. Okay. So, let's say we have a function 2x squared plus x minus 4. All right, and they want you to find f of 1. All right, now, don't make this any harder than what it is, okay? Because, like this could be on a quiz question or something, right? I give you a function, I say, I just want you to find these. All you got to do, normally they'd be an x here, but we got a 1. So wherever there's an x, we're just going to put a 1 in there. Right? That's all you're going to do is put a 1 in there. All right, so I'm going to move this guy over here a little bit. It's too close. Get it out of the way. So I'm just going to go like this. 2 times 1 squared plus 1 minus 4. All right, I can do that in my head. I'll put it in decimals, have it figured out for me, whatever you want. But that's all you're doing is just taking that 1 and substituting it in wherever x is. And now I just work it out. So let's see, this is 2 plus 1. So this is going to be negative 1. Okay, 1 squared times 2 is 2, plus 1, 3 minus 1 is going to be negative 1. All right, that's that. Okay, same thing here. Now x is negative 2. All right, so wherever I see an x, I'm going to put a negative 2. So put a 2 there. All right, put a 2 there, minus 4. The reason why I made this negative is because I want to make sure that if you do type this in decimals, that you put a little parenthesis around that, because if you don't, it's probably not going to do it correctly. All right, it does the order of operations, which means it's going to square first. So what it might do is take that 2 and square it and then make the answer negative, which is not what the problem's saying. The problem's saying that we want to take negative 2, square that, and then work it out. Okay, so this would be 4 times 2 minus 4. So 8 minus 2 is 6, minus 4 gives me just regular old 2. How about that? All right. So you want to make sure you're careful with the negatives when you have a square. All right. So if you type that in the decimals, make sure that you put the little parenthesis around it so it knows that you want to take negative number and square it. All right. If it just gives you an A, well, okay. So wherever I have an X, I now have an A. I can't do anything with it. I'm just putting that in there. Okay? Don't make it any harder than it is. Just, all right, well, X is now A. I don't know why, but it is. So I put an A in there. All right? So they'll have problems like that. Okay? Any questions on those? How to do that? Man, I don't know what just happened. We're cruising on this. I don't know what just happened. I think, let's see. Oh, it must reset itself. Well, let's see what happens here. Okay. All right, so that's that. All right. The other problems they're going to give you in this section, this is all 1. See, now they're going to introduce g of x. All right, and then we're just going to ask you to do some operations. Okay. All right, so I'm going to show you a couple different things here. First of all, this is how they write it in the book, and this is another thing I don't like. They do it like this. Okay? It says f plus g with an x like that. All right? Now, I personally like to write it like this, because that's easier. Okay? I remember I was doing a class and we did this, and then I quizzed them on it. I did this thing, and I caused so many problems. Well, what do we do? Right? But and I said, hey, you guys want me to write it like this? And they said, yes, please. Okay, so then all I did was just always write it like this. But your book is going to do this stuff. Okay? So they are the same thing. All you're doing is taking these two functions and you're just adding them up. So you would take x plus 3, that's one of them, right? Plus negative 4x minus 1. All you're doing is just adding those up. All All right, it's the same thing, but the notation and how it's written, this seems to make more sense for people. Okay? So you'll see most of my stuff written like the bottom one there. It's the same darn thing. Now you got to finish it though. Okay, so we're going to add up our like terms. X and negative 4x, 3 and negative 1, and there's the answer. All right? But that's all you're doing. Okay? You're just adding, and it's just, the book does it one way. All right? I kind of like to do it the other way. Here we'll do the same thing here. We'll do a subtraction. So that's going to look like this. F of x minus g of x. So now I'm just going to subtract them. So I'm going to take x plus 3, that's my f function, minus, I'm going to put this in parentheses, 4x minus negative 4x minus 1. That's my g function. Okay? These things are the same. Now I just got to work it out. All right? Moving this guy inside here is going to change those. So I'm going to get 5x and 4. All right. All we're doing is subtracting them though. Okay. This is just real basic operations. Just combining like terms. You're just taking the two functions and combining them. All right. You'll see something like this. Okay, I would write that as f of x dot g of x. So now we're multiplying them. F function times the g function. All right, they mean the same thing. A little dot just means times. All right. So now we're going to times these. So to times them, what would we do? Anybody have any ideas? Yeah. Yeah. Foiling, huh? Yeah. I bet your number probably foil a bunch if you took some math classes leading up to this. All right. So we're just going to FOIL this. Good job. Minus x. Okay. And I'd probably do this in my head. I mean, you know, you guys could do it in your head. I'm writing it all out. There we go. Okay. But you're just doing operations on them. So it's almost like, you know, stuff you did before. Where you're just combining like terms. You just take these two functions, whatever they are, and combine the like terms. Okay. Here, you're just going to FOIL them. Right? They gave you some division ones, but I don't know if I gave those or not because they don't really do much. Maybe. We'll do a division one, I guess. How do they do that? F divided by F divided by G. X like that. Okay, so I would write this as f of x over g of x. And really not much you can do here. So you just have x plus 3, okay, over negative 4x minus 1. Nothing you can do. You can't divide them, so you just leave it alone. All right. So most of the time you're just going to leave it. You can't do anything with a division. All right. So that's operations on functions right there. All right. And finally, that's the end. All right. That's all there is in section 1.1. Okay. Questions on 1.1, which is a whole bunch of stuff? Okay, 1.2 is way less material than this. All right? But you're still doing the same thing. And let's do, let's go back. I'm going to go back into Desmos again. I think we can accomplish what we need to do by me doing it in here. By the way, you can enter these as functions. So if you go f of x like that, okay, it'll let you do it. And one of the nicer things about it is you come down here and say, okay, tell me what f of -2 is. It tells you, okay, it puts it right in there and tells you what it is. All right, so that's kind of nice. If you define them as functions, it will do that. All right, but I don't think it will do any really symbolic manipulation. So if we do this and I go like this, let's go x squared minus x plus 1. Oops. So there we go. And I come down here and I go, hey, would you do this? We'll go f of x plus g of x. It graphs them, whatever the answer is, but it won't tell you what it is. Okay? So you have to actually do the same thing. So it doesn't do the composition. It doesn't understand that. It's not that powerful. All right, I want to do this here. Let's go y equals oops. There we go. Okay, so let's look at something like this. All right. So here we have a little graph like this. Okay. It's going to ask you some questions about these graphs. And one of the things it's going to ask you about is the domain of range. Okay. So it's going to give you some funky looking graphs, and it's going to ask you, hey, what's the domain of range? All right. So let's say this is one of them. What do you think the domain of this is? Right, all real numbers, okay? All right, what about the range? Is it ever going to get to 0? You think? Okay, probably isn't ever going to get to 0. Okay, this 0.8 really has nothing. It's just raising it up. It's probably never going to get to 0. All right, if I zoom out, you might get real close to it. See how close we're getting on either side of it? But we're never going to get to 0. Okay? It's really hard to tell that from this thing, but from the visualizing, you can kind of trace on it and see. All right? All right. So y greater than, not equal to, greater than 0. Okay? So there's a domain of range. It's going to ask you if it has any intercepts. Okay? So what it means by that is two types. Number one, does it cross the x-axis? Right? If it crosses the x-axis, those are x-intercepts. All right. So in this case, it's never going to cross the x-axis because we just said that the range is always positive. This doesn't have any x-intercepts. I'll show you some that do. It does have a y-intercept. Okay, and they will list them. This book will list that, even though this y-intercept is really not that exciting. Okay, it's 1.25. All right, you can click on it and it will go right to the intercept. Goes right to it. Okay, but there are no x-intercepts. So we would say this has a y-intercept at 1.25. It's going to ask you about intercepts. It's going to talk about symmetry. Okay? So what do they mean about that? Well, symmetry about the x-axis, okay, means that if I fold this over, will it match up? Will the graph be the same? Well, there's nothing to match up down here, so this doesn't have symmetry with the x-axis, so there's no graph down here. It's all up here. Okay, so there's no symmetry with the x-axis. But with the y-axis, if I fold it over, okay, it's going to match up. Right? So we would say this has symmetry with the y-axis. It's going to match up. Okay, I can fold it over that axis and it will match. So, domain and range. Domain's all real numbers. Range, greater than or equal to 0. Y-intercept, 1.25. Symmetry around the x-axis, no. Y-axis, yes. All right. So here we're going to do another one here. Okay. I'm going to make up some stuff. Let's just do one of these guys here. All right, here's one here. Okay? All right, so domain and range. What's the domain of this? All real numbers. Okay? All real numbers. If I fold this, fold this, fold this, again, it's so hard, okay, to see that. This is tapering. If we bring it here, bring this down, push this up, bring this down, it's going to cover everything on that x-axis. Okay, what about the range? All real numbers, right? It's covering everything on the y-axis. The y-axis is covered by anything on this graph. Okay, if I slide over, I get all real numbers. Domain and range are all real. Intercepts. Here, I'm just going to click. See? It will let you do that. If you're using your phone, you can just touch on it. Okay, there's my x-intercepts. 1, 2, 3 of them. -1, 1, and 3. These are my x-intercepts. All right. Y-intercept, touching on it right there, 0, 3. Okay. All right. I don't know. This is a different point, so ignore that one. 0, 3 is the y-intercept. Okay. Let's get rid of all of those. X-intercepts, y-intercept. All right. Symmetric about any of the axes? Can I fold it over the x and match up? No, I see Ped's going, nope, sure can't. Can I fold it over the y-axis? No, has no symmetry. All right, it just doesn't. Okay, we'll turn this one off. Let's go y equals. Okay, we'll do one of these guys. These are going to be good. All right, and they're going to go from, let's do, yeah, let's make this just a little bit bigger. Okay, there we go. All right, that looks like a mustache sort of thing. All right, okay, domain and range. -6 to 6, because it starts here, stops here. All right, -6 to 6. What about the range? 1 to 1. All right, so if I, again, all right, fold this down, fold it up, okay, it's going to go from here to here. Okay, on the range, only from here to here. All right, so you could probably write that. Oops, that wasn't a good idea. You can write that as well, they're going to hate me tomorrow. So domain, okay, I would go -6 to 6. If you like interval notation, you can use brackets on that because it's going to contain those. Okay, range, -1, using y for range though, right? Or -1, 1. All however you want to say it. That's our domain and range. What about, let's see, we got intercepts. Here, 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 and here. Okay, 4 x-intercepts. All right, 1 y-intercept. Is it symmetric about the x-axis? Will fold down and match up? No. Is it symmetric about the y-axis? Yes. Right. You fold it over, it's going to match up. Okay? And that's what they're going to talk about. All right? The only other thing in this section is going to give you a function, and it's going to ask you different information. So let's go ahead. I'll put one in. I can stay in Desmos here because okay, so it's going to say is the point 2, 3 on that graph? Well, I can see that it's not, so I can graph it and see that it's not on there. Okay, or I could simply put 2 in here. So let's say I address this. Let's say I go back and I say, you know, I'm going to make this a function, f of x, boom, like that. And I could just say, okay, do this for me. Tell me what f of 2 is, right? Okay. Oh, it's 7, but it's supposed to be 3, so no, that's not on there. All right. So you can either plot it if you want to and see, or you can just say, hey, I'm going to put 2 in there into this guy, figure it out and see what I get, and I get 7, but it's asking me if it's 3, so 2, 3 is not on there. All right. If it was 2, 7 instead, then yeah, it's on there. Okay, because 2 in here, you can't see it because there it is right there. All right, it's on that point, on that graph. And so they're going to ask you questions like that. All right. Really, it's pretty much the same thing as we just did. It's just that instead of giving you a graph, it's going to give you a function. Okay? And you're just going to mess with it from there. All right? That's all there is to 1.2. 1.2 didn't have a whole heck of a lot, but 1.2 had a lot of stuff in it. All right? You got any questions on anything here? Any questions at all? No? You just want to go home, right? You just tell me, yeah, we're tired, we just want to go home. Okay. Yeah, well, if you come up with anything, all right, send me an email or whatever, and so we'll have a quiz on some of this stuff on Wednesday. Again, you know, do what you can. I wouldn't do every single problem, but I would do is, you know, handful in each section, so you know what you're kind of doing. Okay, and okay, if you have any questions, I'll stick around. Otherwise, have a great evening. See you on Wednesday. You want to take pictures?
Yeah.
Sure. Go ahead. What do you want?
I'll let you know.
Yeah, I get that. Yeah, whatever. Yeah, I'll record it, so you'll have it.
All right, thank you.
Yep.
So, which pages?
54, and there you go, right there.